Hello viewers on YouTube. In today's video I have this motor. This is an AC motor. It's a gear here on top. Well, I can't even spin it, very hard. Anyway, we are going to convert this motor into a generator. Here are some details for this motor. This is 25 watts, one phase. Okay, and the rest you can see it right here. So all of these, we're not going to deal with all of this. As I said, we're going to convert it into a generator. So let's focus on here. They say is 25 watts. So I always say this in most of my videos, that this watts is a power consumption when this motor is getting 220 volts AC in order to spin. Okay, this is the power it takes, 25 watts. Okay, but once we convert it into a generator, it's not going to be 25 watts anymore. We're going to multiply those watts times 2 or times 2 plus. Okay, so we're going to confirm about it soon, but for now let's open it and see what we have inside. And just to say, this motor, I found it from 3D printer. It has some problems, so I disconnected it. Oh, okay. Here is a gear system inside. Oof, missing my hands. Oh, now it's spinning. Beautiful. But let's put it back. For now, we have nothing to do with this, so let's keep it aside. Can stay right here. Uh-oh. Very bad. Now this guy looks like what we have to do is to push this out. Okay, here is the rotor. Very beautiful. Wow. Shining. All right, but this is what we need to see and to check. Put it closer. See the wires they use in their winding. Small wires, but not very small. Okay, for me, according to my eyes and what I see here, this is 0.2 millimeters. Okay, 0.2. See, as I said, this is not a mesh wire, just a small but nice and perfect size for what we're doing here. Okay, so I believe that this is going to produce nice voltage. So as I said, we're converting this into a generator. In order to convert it into a generator, we have to make this to become magnetic, because right now, as you can see here, it has no magnet. Okay, there's no magnet in this. So it's either I have to cut it and put the magnet, then put it back. But this is so adorable. It's beautiful. I don't want to damage it. So I'm going to keep it and find something which can fit here and leave some space aside and use that space to put our magnet. So that, because I didn't have anything else metal like this, so what I have to do, I made a small, okay, so after making this piece of wood, I put these 4 poles of magnets, north, south, north, south. Okay, so I hope it's going to work out. I believe so. One way to find out. Okay, right there we are at the middle, and this we're going to use the same. Likely they use the same bearing just like the one I use all the time. Ooh, there we go. Okay. Okay, there we go. Alright, now let's check if we are making some volts. Let's put it on 200 volts AC. Now, one thing I did not explain is that here you can see we have 3 wires coming out. So what it means here means we have 2 windings inside. One winding for starting and another winding for full speed. Okay, so this neutral is just where 2 windings have mated together, and this is another winding, this is another winding. So this place, that's where they connect a capacitor. One terminal of capacitor goes to this side and one to this side, then goes with this to receive the power. Okay, so these 2 windings, they both connected in series. Like I said already, this is the center. So if we need to get high voltage, we should use this. Okay, these 2 wires, not this center. Okay, so one to brown and another end to white. Okay, now let's see. Well, we're making about 11 volts. Depends how fast you spin it. So let's try it with a rope, even though the magnet inside are not secured, but I believe this is going to work out. Okay, let's put it this way. In case we went over 200, let's go to 750. Our multimeter can measure the voltage to 750. So let's see. Oh, sorry for that. It was facing the light, so let's do it again. One more time. 113. Okay, let's see this time. Let's try to put the whole rope in. Okay, enough. Ready? 124. Okay, right now 124. Let's try to power something. First, I have this 9 watts light bulb, as you can see there. Let's see the 9 watts. Remember, they said it's 25 watts. This motor is 25 watts, or it was 25 watts. So now let's see if we can generate the voltage more than 25 watts power. What's going on? It's my throat. Okay, believe this is enough. Ready? I want you to see. Let me put it this side. Okay, that worked. 9 watts. Okay, so let's try something bigger, which is this 30 watts light bulb. So this one, check out the details of this light bulb. See there, 165 to 265 volts, 3 amps max. Okay, so let's see if we can be able to power it. I know what you're thinking. This is starting getting, they said you can be on from 165 watts, 165 volts to 200 something volts, 265. And here we made about 124. Well, like I said, it depends on how fast you spin it. Okay, so here they said minimum 165. So I'm going to try to pull it very fast. Then I'm going to try to put all of this rope just to see if we can reach that 165, or maybe more than 165. So let's put all of this. Right. Ready? Yes. Hope you see the light came out from it. Do I have to do it again? No. Let's take this out. That's 30 watts. You see how bright it went? Well, remember this, they say 25 watts, but we just powered here this 30 watts. Be there, don't worry. I know what you're thinking about. This is just the first test. There is more. Now, let's go to 55 watts. 55 watts, which is about times 2 to this 25 watts. Okay, here, this is 55 watts. Right, so because this can move, so let's put it here. I hope you can see it when it starts shaking. Yeah, and it's gonna make some noise. Okay, you know what, let's just put it like this so it can be easy for you to see it if it's going to move. well, not too hard. You can feel some resistance, but not too hard yet. That means it's not overloaded with 55 watts. That's one way to find out. Okay, please. No short circuit. Right. Uh-oh. So when it comes on, it's going to move. Ready? See that? Well, should I go far with this? I'm coming there. We're gonna spin it with a DC motor in this video, not in next video. So let's see. This is 100 watts light bulb. Okay, not these. You cannot compare these to these ones, because these ones inside, it's like this. They convert AC to DC, like 24 volts, these ones. But these, you know about them, you have to burn that element inside in order to be on. So let's see, 25 watts versus 100 watts. Are we going to see the light from there? Anyway, one way to find out is without load. Let's see with the load. Yeah, now I can feel the resistance. I can feel it, but that is not going to stop us. Let's use the rope first before we attach our generator to a motor, DC motor, to spin it. We're going to use 775 DC motor, but first, before that, let's see. Ready? Eyes right here. 3, 2, 1. You see that? That's 100 watts light bulb. Okay, so right now I'd like to do this. Let's stop with this. Now we're going to bring this right here, and here is our motor. We're going to use this battery to spin this motor just to see the full speed of our 55 watts machine, and to see maximum bright we can get from this 100 watts. Okay, so whether it's going to be the same light or maybe it's going to be more than that, one way to find out. This is our motor. Very fast, very strong. So be there. When I just pause, you're gonna see like there's a jump. Pause to do all this arrangement, then come back. Done putting anything else together, as you can see here. Oh yeah. Okay, so these wires here, they're for this DC motor. Okay, and here are our outputs. This one, we're not using it. Anyway, maybe before I cut it, we have to do this. Like I said, in this motor, there are 2 windings. This is the center. Let's say you don't want to use both windings. You need to use one winding at a time, or maybe you want to make it as a two-phase. Well, it's easy. All you have to do is to connect one right here at the center. Center is going to be your common wire, and another winding is going to power this light bulb. Okay, and like I say, this black is the center, then another blue or black wire from another device or another motor is going to be there, another light bulb. Then live wire for that light bulb is going to be connected to this. I'm saying if you want to maybe make two-phase. Okay, so each and every winding here is working on its own. Okay, this is separate. One winding is powering this, one winding is going to power this light bulb. Okay, so first test, as I said, I'll be using this battery. Okay, 12 volts, on off first, negative for battery here, just like this. Okay, so ready? Okay, see that? Let's see another one. If it is coming on, let's make it face us. Okay, this and that. Yes, all of them, they are working, or they're giving power. So right now, yeah, let's go on with this. This is 9 watts, this is 6 watts. Well, you can't see properly, but this is 6 watts, this is 9 watts. This gonna give us some problems, I don't know, but let's connect this on this 9 watts, or the phase which is powering 9 watts. Let's hear the sound this time of this. Okay, and here our negative is out again. Okay, let's try do something else, like okay. Right, now make sure wires are not touching each other, and make sure you're not touching them. Ready? Oh, did you see here? Yes. Well, one phase is powering this. Okay, one winding is powering this 55 watts, and remember this, they say it's 25 watts, but we are able to power this with just one winding, 9 watts plus 55. Okay, you do the math, 60 watt, I don't know. Okay, plus this one, another side. Okay, so let's see that winding, if something else can be connected there. So I'm connecting this 30 watts in that winding. I don't know if we are going to make it. One way to find out. Oh, not here, but right here on the neutral. All of them. the neutral, the same one, all of them, they're getting the neutral from the black wire. So here, one light bulb, this one and this machine are using white phase, one winding, and these 6 watts and these 30 watts, they are also connected on the other winding. So let's see. Yep. See that? This side we have 36 watts on the other winding, and the other winding we have 55 and 9 watts, which is 64 watts. 64 watts, 36 watts other side, and no any problem here. You can see this, how is it spinning. See that? And let's check the voltage. Let's go back to 750 volts AC. I hope we're going to be able to see the numbers. Which one? We should check this one first. Neutral, right here. Okay, this is a neutral, and the phase, we're checking one winding, which is this winding. So let's face that side so we can be able to see the numbers. Okay. Yeah, there's no point, so let's hold it like this. Okay, after pouring all of this in this phase, we are able to remain with 83 volts. Okay, 84 volts. I believe once we connect to all of this, just like one, I believe the remaining voltage can be over that. Okay, now this was 2-phase mode. Now let's go to single phase. Single phase, that's where both windings are connected in series. So in there, you're going to power 100 watts, because I don't think with one winding we can be able to power 100. So okay, one way to find out, 100 watts is connected to one winding. Okay, brown wire is not used, only one winding. Okay, let's see if we can be able to power it with one winding. Oh, okay, it's happening. But now I need you to notice one thing. With one winding, see the light which is coming out. Okay, that's one winding. Now let's see with both windings connected in series. Now let's see how bright it's going to be. Okay, well, for me I can see some difference. I don't know about you. Okay, so they said it's 25 watts, but we are able to power this 100 watts. That means what I said was right, because I said it can be 25 watts, but when it's receiving 220 volts to work as a motor. But once you convert it as a generator, then the watts are going to be multiplied times 2, or maybe times 2 plus. So let's see now. We're powering 155 watts. Let's see if this is going to be on together with the light bulb. And you see there, start spinning. Okay, this is too much. You can see how the light is coming on and the speed of this. Oop. Okay, that's too much. That's overload. 109 watts. Yeah, this one is good. Okay, so I'd like to stop right here. Thanks for watching. This is all that I have in this video. I hope you enjoyed. Please don't forget to subscribe. Let's get it to 1000. Share this video to others so they can learn how to convert the motor, normal motor, whether it's a fan motor, into a generator. Okay, we have a lot of videos to come. Just keep sharing the video so anyone else can learn how to make these type of beautiful motors. Thanks for watching.